Welcome to The Explainer, where we break down big ideas.
Today, we're diving into a pretty wild idea that could take construction waste, a massive global problem, and turn it into a seriously futuristic solution. Here's how we'll walk through it. First, we'll get a handle on the huge challenge we're facing today. Then, we'll get into this incredible new idea step by step, from using ice to biology. And we'll wrap up with what this could all mean for the future. All right, let's jump in. So every single time a building comes down, it creates just a mountain of waste. And you might be surprised to learn that what we do with it right now is incredibly basic.
Right now, we're stuck in what's called downcycling. We basically just crush old concrete into cheap filler for roads. It loses almost all its value. And worse, the process creates a ton of contaminated dust and wastewater. The goal, the dream, is to switch to upcycling, where we can transform that same exact rubble into something even more valuable, like high-tech building materials, all while capturing CO2 and recycling water.
So how do we get there? Well, a new process called Clean Recast is aiming to do exactly that, to achieve true upcycling for all that construction waste. In simple terms, it's basically a recipe. It's a blueprint for taking that messy jumble of crushed concrete, brick, and dust and turning it into smart, self-healing building blocks. And we're not just talking decorative pavers here. We're talking about panels that are actually strong enough for structural use. Okay, so how on earth does it work? Well, the very first step is all about getting the raw material super clean. And they do it using a tool you probably wouldn't expect: ice. Yep, you heard that right. It's kind of like freeze distillation, but for rubble. The waste gets ground up with water into a thick slurry. Then it's chilled to a very specific temperature, just below freezing. What happens next is pretty cool. Pure water crystallizes into ice, and as it does, it literally pushes all the contaminants, the salts, gypsum, and other gunk, into a concentrated liquid brine. It's a brilliant way to get a perfect separation. And what's really beautiful about this system is that there is no waste stream. There are only different product streams. You get pure water you can reuse, you get valuable solid crystals for other industries, and you get this calcium-rich brine, which just so happens to be the key ingredient for the very next step. And we're talking about a seriously efficient process. The goal is to recycle at least 90% of the water used. That creates a nearly perfect closed loop, making the whole thing remarkably self-contained and sustainable. Okay, so we have this calcium-rich brine. What's next? Well, now it's time to bring in a microscopic cleanup crew that does two incredible jobs at once. The secret weapon is a natural enzyme called carbonic anhydrase. This thing is one of nature's fastest workers. And get this, it loves the cold, which is perfect because it means the process can flow seamlessly right from the ice separation step into this one. Now, this is the part that is a real game changer. The enzyme pulls CO2, a pollutant, right out of the air and uses it to turn impurities in the brine into pure calcium carbonate. So you're not just cleaning something up, you're permanently locking away a greenhouse gas and turning it into a valuable building block for the final product. Amazing. All right, let's recap where we are. We have clean water, we have recycled aggregates, and now we have this amazing filler material made from captured CO2. All the ingredients are prepped. It's time to actually build the final product. Instead of using carbon-heavy cement, Clean Recast uses what's known as a geopolymer binder. And instead of steel rebar, which can rust and degrade, it uses reinforcement made from natural fibers, like basalt or even flax. But here's where things get really futuristic. This isn't just a strong panel, it's an intelligent one. It's designed to act almost like a living system. It has a smart skin that can literally feel stress and damage. And it has embedded channels, almost like veins, that can deliver a healing agent when it's needed. I know, it sounds like something straight out of science fiction. So how does a wall actually heal itself? Well, it's this brilliant four-step cycle. First, the smart skin senses a problem, like a microcrack you could never see with your own eyes. Then, a tiny computer decides what to do. It analyzes the data and triggers a response. Third, it acts, releasing a small pulse of biological healing agents right to the site of the crack. And finally, it verifies. The skin monitors the area to make sure the repair is complete. The wall is actively extending its own lifespan.
And just in case you're thinking these are some kind of weak conceptual panels, think again. They're designed to be as strong as conventional structural concrete, making them totally suitable for use in real-world buildings.
So, what does this all add up to? Let's zoom out and look at the big picture. When you compare this to what we do now, the difference is just staggering. Clean Recast doesn't just reduce environmental harm, it creates brand new revenue streams from what everyone else considers worthless trash. It completely flips the economics of demolition on its head. What we're looking at here is a shift from that old, wasteful, linear model of build, demolish, dispose to a truly circular one of build, demolish, recreate.
And this really matters because it shows us a pathway to building smarter cities, cities with infrastructure that's built with its environment and can adapt to it rather than just sitting there.
So, this leaves us with a pretty powerful question. Are we on the verge of creating buildings that are literally born from waste and can behave like living organisms? It's a wild thought, but with innovations like Clean Recast, the answer might be a lot closer than we think.